Today we are here with the chapter 1 of physics class 9th, that is motion. So let's begin this chapter. Okay, let's talk about motion. What is motion? Let's watch here. An object is here at position A when the time is 0. Then it comes to the position B at time t. It means within time t it changes its position from A to the position B. Means this object is changing its position with respect to the time. Then this object is said to be in motion. So we can say that an object changing its position with respect to time is said to be in motion. Okay, now let's talk about distance. Watch here. A person is starting from the point A and is following this path and reaching to the point B. So this person is traveling this total path to move from A to B, and this total path traveled by this person or object is called distance. So we can say that the total path traveled by an object in motion from initial to the final position is called distance. The distance is represented as s. It is a scalar quantity. So what is scalar? We will discuss it later. And its unit is meter, since it is length. That's why the unit of distance is meter. Now let's talk about displacement. Watch here. This path we have already talked about. Now let's talk about this path. This is the shortest path to move from A to B. This is the shortest path followed by this person to move from the point A to the point B, and this shortest path is called displacement. So we can say that the shortest path traveled by an object in motion from initial to the final position is called displacement. It is represented as vector s. It is a vector quantity. We will discuss what is a vector, and its unit is also meter. Now let's talk about scalar quantities. Watch here. We have already talked about this distance. When we talked about the distance, we don't care about the direction. We can move to this direction, this direction, this direction, this direction, this or this. Whatever the direction we need to follow, we can follow. So here is no bondage of the direction. So the quantities which don't care about the direction, only they need the magnitude or the amount of the path or the quantity. They only need the amount or magnitude of the quantity and don't care about the direction. Those quantities are called scalar quantities. So we can say that the quantities which require only magnitude to define them completely are called scalar quantities. So for example, the scalar quantities are distance, time, etc. Now let's talk about vector quantities. We have discussed about this displacement. In case of displacement, a direction is specified which is from A to B. It is not free to move in any of the direction. It is only free to move from initial to the final position. So we must define the direction in case of displacement. So we need magnitude as well as direction. So these kinds of quantities which require magnitude as well as direction are called vector quantities. So we can say that the quantities which require magnitude as well as direction to define them completely are called vector quantities. For example, these are displacement, force, etc. Now let's talk about the speed. Okay, watch here. Here an object is at position A and at the time 0. At time t, it comes to the position B. It means within time t, it moves from position A to the position B. And while moving from A to B, it travels a distance s. So with respect to time, it is traveling a distance s. In this condition, if an object travels a distance s within time t, the speed of the object is given as this. V is equal to s upon t. Speed is equal to distance upon time. This is our formula for speed. This is the expression for the speed. So with the help of this formula, we will define what is speed. Let's see. Watch here. We will take this t as 1. So if we take t as 1, then v is equal to s. If we take t as 1, then v is equal to s. And we can read this to define the speed. So watch here. The distance traveled per unit time by an object in motion is equal to the speed of the object. What we have done? We have taken the distance traveled per unit time by an object in motion is equal to the speed. So let's read that out. Hence, the distance traveled per unit time by an object in motion is equal to the speed of the object. The speed is represented as v. Its unit is meter per second. Meter for the distance, second for the time. And it is a scalar quantity because speed depends upon distance. That's why it is a scalar quantity. Now let's talk about uniform and non-uniform speeds. Watch here, uniform speed. Here is an example of distance traveled. An object which travels 5 km in the first 1 hour, again 5 km in the next 1 hour, and again 5 km in the next 1 hour. So this object travels equal distances in equal time intervals. Then the speed of the object is said to be uniform speed, and the motion is called uniform motion. So we can say the speed of the object which travels equal distances in equal time intervals is called uniform speed, and the motion is called uniform motion. Here the speed of the object is constant, in this case 5 km per hour, in this case 5 km per hour, in this case 5 km per hour. So we will say the speed is uniform or constant, which is 5 km per hour. Now let's talk about non-uniform speed. Watch here. An object travels 5 km in the first 1 hour, 10 km in the next 1 hour, and now 15 km in the next 1 hour. Then this object is traveling unequal distances in equal time intervals. So we will say that this speed of the object is non-uniform speed and the motion is non-uniform motion. So we will say that the speed of the object which travels unequal distances in equal time intervals is called non-uniform speed, and the motion is called non-uniform motion. Watch here. In this case of the non-uniform speed, we will calculate the average speed. The speed of the object is non-uniform, so we need to calculate the average speed. The average speed is given as total distance upon total time. The total distance in this case is 5 km plus 10 km and 15 km, which becomes 30 km. And the total time is 1 hour plus 1 hour plus 1 hour, that becomes 3 hours. Now we will divide this 30 by 3, then we get 10 km per hour. This is the average speed throughout this non-uniform motion. Now let's talk about velocity. Watch here. When the direction is specified with the speed, we have already talked about speed. When the direction is also specified with the speed, then we get the velocity. So if an object travels a displacement s within time t, then the velocity of the object is given as this. This is the expression for the velocity. Vector v is equal to vector s upon t. This is the expression for the velocity. Now we will define velocity with the help of this expression. Watch here. We have taken this. We will take this time as 1. If we take t is equal to 1, then vector v is equal to vector s. Now we will read this. The displacement per unit time by an object in motion is equal to the velocity of the object. What is this? This is the displacement per unit time by an object in motion is equal to the velocity of the object. So we can say that the displacement per unit time by an object in motion is equal to the velocity of the object. The velocity is represented as vector v. Its unit is meter per second and it is a vector quantity. Now let's talk about uniform and non-uniform velocity. Watch here, uniform velocity. If the velocity of the object is not changing with time, that is, it travels equal displacements in equal time intervals, as we have discussed in the speed. So its velocity is called uniform velocity. What happens when it travels equal displacements in equal time interval? Or we can say the velocity of the object is not changing with time, then it is called uniform velocity. In this condition, the initial velocity will be equal to the final velocity and the acceleration will be 0. What is this acceleration? We will discuss it later. Now, let's talk about non-uniform velocity. So watch here. If the velocity of the object is changing with time, that is, it travels unequal displacements in equal time intervals, then it is called uniform velocity. In case of non-uniform velocity, it travels unequal displacements in equal time intervals, or we can say the velocity of the object is changing with time. In this condition, if the velocity of the object changes from u to v, u is the initial velocity, v is the final velocity. If the object is changing its velocity from u to v, then we need to calculate the average velocity in case of non-uniform velocity. So watch here, the average velocity will be given as u plus v upon 2, the sum of the velocity upon number of velocity. Hereby we can calculate the average velocity, which is u plus v upon 2. Now let's talk about acceleration. What is this acceleration? Let's begin. If the velocity of an object is changing from u to v within time t, the velocity is changing because it is non-uniform velocity. It is changing from u to v within time t. Then the acceleration in the motion of the object will be given as this: a is equal to v minus u upon t. This is the expression or the formula for acceleration. This we will use to solve the numericals. This is the formula for acceleration, and with the help of this formula we will define acceleration. So watch here, this is v minus u, means the change in velocity, the change or difference in velocity. So we will write it change in velocity. So we can say that acceleration is equal to change in velocity upon time. Okay, whenever a quantity is divided by time, then the quantity becomes its rate. So the change in velocity is divided by time, so we can say that this is the rate of change in velocity, which is equal to acceleration. So we will say that the rate of change in velocity of an object in motion is equal to the acceleration in the motion of that object. The acceleration is represented by a. It is a vector quantity and its unit is meter per second square. Now let's talk about some equations of motion. There are three equations of motion. Equation first is v is equal to u plus at. V is final velocity, u is initial velocity, a is acceleration, and t is time. Equation second is there. S is the displacement, u is initial velocity, t is the time, half is a constant, a is the acceleration, and t is the time. Here is equation third. V is final velocity, u is initial velocity, 2 is a constant, a is the acceleration, and s is the displacement. So we have three equations of motion. We must memorize them. V is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. These are the three equations we must memorize. Now we will prove these equations one by one. So let's prove equation first, which is v is equal to u plus at. So this is the proof of the first equation of motion. Let us consider the velocity of an object changes from u to v within time t. then the acceleration will be given as this. This is the formula for the acceleration we have already discussed here. Acceleration is equal to change in velocity upon time. The change in velocity is v minus u within time t, and the acceleration is represented as a. So we will take this t to get multiplied with this a by cross multiplication. So this becomes at is equal to v minus u. Now we will take this minus u, we will take this minus u to this side. Then this negative u becomes positive when it comes to this side. It becomes u plus at is equal to v, and we can write it like this: v is equal to u plus at. And this is our first equation of motion that we needed to prove. Alright, now we will prove the second equation of motion. This equation second, s is equal to ut plus half at square. Okay, how to prove? Let's discuss. This is the proof of the equation second. Let us consider an object moving with the speed u, displaces by s with an acceleration a within time t, and gains a velocity v. Then the average velocity into time will be given as displacement. So the displacement in this case is average velocity into time. We have already learned the formula of displacement, which was displacement is equal to velocity into time. But in this case, the velocity is changing from u to v. This from u to v means the velocity is changing. The velocity is non-uniform. In case of non-uniform velocity, we calculate the average velocity. That's why we have taken displacement is equal to average velocity into time. Now put the values of this. The average velocity is u plus v upon 2 into the time is t, and displacement is represented as s. Now this t and this u plus v upon 2 multiply to give displacement. Okay, from the equation first, we know that v is equal to u plus at. V is equal to u plus at. The value of this v we will place here. In the place of this v, we will place value of this v, that is v is equal to u plus at. So place this u plus at in the place of v. What happens? This happens. In the place of v, we put here u plus at. Now watch here, this u and this u sums up to give 2u. So this becomes 2u at as it is upon 2 into t as it is. Now what we need to do? We need to separate these two terms, 2u upon 2 plus at upon 2, like this: 2u upon 2 plus at upon 2 within a bracket, and t is outside. Now watch here, this 2 is cancelled by that 2, and we will get u plus at upon 2 into t. Now we will enter this t into this bracket, and it will be multiplied with u to give ut, and it will multiply with at upon 2 to give at square upon 2. And this we can also write it like s is equal to ut plus half at square, which is our second equation of motion. This is our second equation of motion that we have proved. Now let's prove third equation of motion, which is v square is equal to u square plus 2as. How to prove this? Let us consider an object moving with the speed u, displaces by s, and gains the velocity v. The acceleration in the motion will be given as this: a is equal to v minus u upon t. Watch here, by cross multiplying, we can take this a over here and this t over there. So this becomes t is equal to v minus u upon a. Let's take this as equation 1. Now apply the formula: displacement is equal to average velocity into time. Here the velocity is again non-uniform, that's why we have taken the average velocity, which is u plus v upon 2 into time t. Now we will put the value of this t from equation 1. from equation 1 we will put the value of this. So let's put the value, which is v minus u upon a. This is from equation 1. We have put the value of t. Now watch here, this is u plus v upon 2. We can also write it like v plus u upon 2. This is u plus v, we can write it like v plus u. So we have put it like v plus u upon 2, and this is v minus u upon a. Now here a formula is applicable over here. Watch here, this is v plus u and this is v minus u. We know that v plus u into v minus u becomes v square minus u square. This v square minus u square, and this 2 multiplied with a becomes 2a. Now this 2a will be multiplied with this s by cross multiplication. So we will have 2as is equal to v square minus u square. Now this minus u square we will take over this side, then it will become positive. So this becomes positive u square plus 2as is equal to v square. We can also write it like this, v square is equal to u square plus 2as, which is our third equation of motion. So we have proved these 3 equations of motion, which are very important. So these 3 important equations of motion, we will solve these in assignments. Okay, thank you for now, see you again.